Section 7.2, connecting intercepts and linear functions. A quadratic function is in factored form when it's written as y equals k times x minus a times x minus b in parentheses. So if we're going to take this should be a refresher from where we ended 6.3 in the first semester. If we're taking something in factored form and trying to make it in standard form, we're essentially going to have to multiply everything out. And in this example here, right, they're multiplying basically this part and this part together. So they get, x times x is x squared, x times the negative 4, negative 4x, 1 times x is plus x, 1 times negative 4, negative 4, and then everything is still multiplied by 2, but you can combine these terms here, and you wind up getting, right, minus 4 and plus 1, it's this right here. We're at this step now, and then the last thing you have to do is multiply everything times 2. And when you do, you get 2x squared, right? And then 2 times the negative 3, negative 6x. 2 times the negative 4 is negative 8. So this is right here, this is standard form. And up here, right where we started was factored form. And there's an interesting thing about standard and factored form that we're going to get to as far as the graph in a little bit. But let's try an example here, right? So you've got basically 3 times this times this. And for those of you that like this method, you could multiply this out using a grid if you don't like FOIL. And there's nothing wrong with that, right? X minus 5, x minus 2, and x times x is x squared, x times negative 2, negative 2x, x times negative 5, negative 5x, and then negative 5 times the negative 2 is plus 10. Now the nice part is if you use this grid method, right, the diagonal terms are always the ones that can combine. So a minus 5 and a minus 2, you're going to get essentially, minus 7x. And then you're left with x squared plus 10. And that's all the terms there. On the part that says multiply the two linear factors, right? I mean, this is what you're doing. And the last step here that we have to employ is you have to take this 3 and distribute it by multiplication. So 3 times x squared is 3x squared. 3 times the negative 7 is negative 21x. And then 3 times 10 plus 30. So the standard form of this thing right here, remember this part here, this is factored. And standard form is going to be 3x squared minus 21x plus 30 y equals, right? And this right here, this is standard form. So as you can see, right, the multiplication of polynomials will be needed. And if you struggle with this, I highly recommend you come out for tutoring, you work on the IXLs, you do the practice needed to understand these concepts, because the second semester it's going to be required that you can do these going forward. So here we go. Let's try a couple of examples. If I want to write these in standard form, remember standard form, y equals ax squared plus bx plus c. It was on my board for about a month. I know it's been a long break, but hopefully you'll remember this. And then likewise, there are many ways to multiply polynomials. I showed you one way, which was the grid way. You can also use the distribution way, and that's where I take the x here, right? X times x minus 1, and then minus 7. Where did I get the x and the minus 7? They're right here and here, times x minus 1. Remember, this was another way we could do this, and we built our problem. X times x is x squared. X times a negative 1, negative x. Negative 7 times x, negative 7x. Negative 7 times a negative 1 plus 7. So now that I've basically distributed and multiplied all this out, this becomes like an addition problem, right? From here on, this carries down. X squared minus 7 and minus 1 is minus 8x. And then, right, there's nothing here to add 7 to. So this is the standard form of, what you started with number 5. So let's try another example. Pick a different color here. So I did that distribution method. I'm going to do a little bit more of the grid, because I really think if you're struggling with this, this is the way to go to do these if you struggle. Foiling is prone to errors, and this way, less errors. So I basically set up, all my things here on the side. I'm going to multiply by 4 in a moment, but first I'm going to get rid of the stuff in parentheses. So x times x is x squared, and x times a negative 1 is negative x. X times 3 plus 3x, and plus 3 times a negative 1 is negative 3. And kind of the beauty of the grid method is all the like terms are always diagonally across from each other. So you still have 4, right? It's still 4 times, but now it's 4 times x squared. 3 minus 1 is 2, right? Plus 2x, and then a negative 3. And now this is a lot more manageable problem now that you've multiplied all the stuff in the 2 sets of parentheses. Right, from here, it should be on easy street. Right, 4 times x squared, 4x squared, 4 times 2 with an x is 8x, and 4 times a negative 3 is negative 12. So the part I alluded to when you were looking at a quadratic function when it's in factored form is in factored form you actually can know the x-intercepts of the parabola, and that is essentially what this example A is trying to indicate. And it works by the principle that, if I have A times B times C equal to 0, right? Either A, let me rewrite that because that's not very neat. Either A, B, or C must be equal to 0, right? And why is 0 so important? Well, if we are graphing a parabola, and let's just say our parabola goes like this, like in example A, and it has an x-intercept basically at 1 and an x-intercept at 3, what is the value of y at these x-intercepts? And the answer to that question is, well, when x is equal to 1, right? What's y equal to in this scenario and this graph that I've drawn for you, right? Y is, of course, 0. And when x is 3, in this scenario, what is y equal to? Y is equal to 0. So when you're looking at something in factored form, right, you're saying, when is y 0? And if I have three things, right, an A, a B, and a C, like my example here, if I'm 2 times x minus 1 times x minus 3, if it's going to be equal to 0, one of those parts is going to have to be equal to 0. So then the question is, well, what makes x minus 1 equal to 0? Well, that is 1, of course, right? And this comes right back down to section 1.1 of Math 1. Right? The only thing that's going to make this equation 0 is when x is equal to 1. And conversely, or in addition, right? What's going to make x minus 3 equal to 0? Well, if you do the inverse operations, right? When x is equal to 3, then of course you would get 0. So in factored form, right? We can tell by looking at this thing that the y-intercepts, or not the y-intercepts, the x-intercepts are going to occur when x is 1 and when x is 3. By the simple principle that, if I'm multiplying things together and they equal 0, which is what I need y to equal to be an x-intercept, one of these things also has to be equal to 0. So I hope that makes some sense, and you're going to, of course, get a lot more practice in this as we work through this section. But let's take a look at this next example. So if we're eventually trying to get this into standard form, right, here's what we have. And we have to multiply this out, right? So we have essentially x squared plus 2x plus 4x plus 4 times 2 is 8, right? And these will combine right here to be 6x. So we have basically 2 times x squared, which is 2x squared, 2 times 6x, well, 2 times 6 is 12, so 12x, and then 2 times 8, which is 16. So that's the standard form, right? This would be the standard form, not the factored form. And if we take a look at this here, the factor x plus 4 indicates an x-intercept of what? Well, right, if I need one of these things to be equal to 0, x plus 4 equals 0, what would x have to be to make this equation, to make y 0, essentially? Well, it would have to be a negative 4. And the x-intercept of negative 2 aligns with the factor x plus 2. And you should have some experience as well as about what a factor even is. Like, right, here's an example. If we're talking factors, we did this in a factor tree, you'll recall. I want to say chapter 3. What are the factors of 4, right? 2 and 2. Well, it's no different in polynomials. What are the factors of 2x squared plus 12x plus 16? And if you did a factor tree on a polynomial, right, the factors would be 2, x plus 4, and x plus 2. So a similar concept between the numbers and the algebra. Factors simply mean, the two things you multiply together to create the product. So hopefully That's making some sense. Now let's take a look. The x-intercepts of the graph of a graph are the zeros of the function. So there is a 0 basically for the function at a -4, right? At -4. That's the answer to this section right here, -4. And there's an x-intercept of -2 as well. And keep in mind, right, this is not the same graph as the one above it. So now let's determine the zeros of the function. And looking at this thing, right, the zeros slash, they're also the x-intercepts. Well, x plus 5 is equal to 0 when x is equal to a -5. So -5 is a 0 and the x-intercept of the function. And if we look at the other factor, x plus 1 equals 0, right? When x is equal to, well, x plus, what plus 1 equals 0? And that's essentially -1. So that's also a 0 and an x-intercept. So what are the 0 and x-intercepts of this function? -1 and -5. And now let's put it in standard form. Right now it's in factored form. So to put it in standard form, we'd have to multiply this out. And I'm going to show you the grid method a few more times. Maybe you're going to like it. X plus 5, x plus 1. Let me see here. X plus 1. And then I just simply draw, some lines to make a nice set of boxes. And then I can proceed with the work. X times x, x squared. X times 5 plus 5x. X times 1 is x, and x times 5 is 5. Diagonally, it will combine. Now this is just one way to multiply polynomials. You can also factor. You can also use the distribution method. There's more than one way. So you get x squared plus 6x plus 5. So this is the standard form. Oh, not quite. We still got to multiply everything by 2, right? We can't forget about this, our -2. And so the final answer, -2x squared. 6 times 2 is 12, but it's -12x. And then -2 times 5, -10. So now let's take a look at example 10, right? What are the zeros of this function? What essentially makes what's in the parentheses equal to 0? So the zeros and x-intercepts of these functions are at 3 and 1. Right, and I hope everybody can start to see that when they just look at the thing, right? If I had x minus 3 is equal to 0, well, what would make that equal to 0? 3. And x minus 1 equal to 0, well, what would make this equation equal to 0? 1. So that's how we came to this conclusion here. And now let's put it in standard form. If I FOR this out, I'm going to get 5 times, right? X times x is x squared. X times a -1, -x. -3 times x, -3x. -3 times -1, +3. And then the last step, I got to multiply everything by 5. 5x squared minus x, and minus 3 is a minus 4, and 5 times a minus 4 is minus 20x, and then 5 times 3, right? This is grade school math, this part, and hopefully this is all starting to make sense. So in this example, which is a lot like the guided practice for this section, it wants you to be able to write the standard form of all these different things and multiply it all out. So let's we take a look at this. It says our x-intercepts are 2 and 5. So that's going to be, right, x minus 2 and x minus 5. And then it gives different values that it wants to put in front of the polynomial. So here is 1, right? Here's when k is 1. And this is basically all the work for that. And this second example is when k is equal to a negative 2. And, right, that's all the work for that. So these are actually solved examples for you to reference while you're doing your guided practice. And of course, if this were on a test, right, I mean, here's actual examples solved step by step when k is equal to 3. So now let's try another example where I kind of walk you through the process. If our x-intercept is negative 3, right, we have to consider, well, x plus what equals 0, right? If we go back to this conclusion, and it says, well, our x-intercept is negative 3. So then negative 3 plus what equals 0. And, right, that, of course, would mean that this here would have to be a positive 3. So the factors we're looking at when with the x-intercept of negative 3 would be x plus 3. And likewise, right, if the y-intercept or the x-intercept is at 4, you know, x plus what equals 0. I set that up. And then I'm going to say x is 4. So 4 plus what equals 0, right? And that, of course, would be a negative 4. So it's going to be x plus 3 and x minus 4. So I hope that makes sense there with that. And then it wants us to use k as 1. So it's going to be 1 times all of this mess. And the standard form when k is equal to 1 for this, right, this is now, you can FOIL it, you can grid it, you can, however you get to the conclusion, right, x times x is x squared, and then we're going to have a minus 4x, but we're going to have a plus 3x, and then a minus 12, and then minus 4 and plus 3 combine. Final answer, x squared minus x minus 12. So that's the standard form of that one. And we've already identified the factors, right? We're going to have x plus 3, and we're going to have x minus 4. But this time we're going to multiply everything by a negative 3. Well, you already know that these two multiplied together are essentially x squared minus x minus 12. All you have to do is then multiply everything by a negative 3. And when you do that, right, you're going to get minus 3x squared plus 3x, because a minus and a plus, or a minus and a minus make a plus, and then minus 3 and minus 12 plus 36. And last up, same thing, except on the outside it's going to be 2. You already know the inside is going to be x squared minus x minus 12. And, right, I mean, we are just basically multiplying everything times 2. So hopefully you're not looking at this and going like, oh, I can't do this. This is hard. Relax a second and just check it out. I mean, we're multiplying by 2. And we can all multiply by 2. 2x squared minus 2x, and 2 times a negative 12, negative 24. So there you go. I know this is a lot of notes, but this is we're embarking on some more complicated mathematics, and some of this stuff just takes a little while to explain. So I'm going to do 2 examples here, and then after you've seen all this, hopefully, and you have your notes, you'll be good to go on the guided practice. So if my x-intercepts are 1 and 8, basically my factors are x minus 1 and x minus 8. So, and then it wants me to figure this out when k is 1, when k is negative 4, and when k is 5. Well, first off, I got to figure out, well, what are these 2 things multiplied together equal? And you're going to get x squared. It's going to be minus 9x plus 8. And if you did all the foiling or all the grid method, you're going to get that as well. So in this case, when k is 1, it's basically 1 times x squared minus 9x plus 8. And that, of course, nothing's really going to happen. The next one's going to be times a minus 4. So here we go. If we multiply everything by a negative 4, then I'm going to try to write neatly. Right? Minus 4 times x squared minus 4x squared. Minus 4 times a minus 9. It's going to be a plus 36. Plus 36x. Minus 4 times a positive 8. Minus 32. And last up, times a 5. Right? You'll notice how this first part is still the same. It's just giving you practice multiplying polynomials. What's 5 times x squared? 5x squared. 5 times a negative 9, negative 45x. 5 times 8 plus 40. So that's one example. Try to partition my work. And let's take a look at this other one. And let me pick a different color. So if I have an x-intercept of negative 7, right, these are the factors of x plus 7. And if I have an x-intercept of 3, it's going to be x minus 3. And then I'm going to have to figure out, well, what happens when k is 1, when k is negative 5, and when k is 7. So, and this k that they're referring to, they mean k as in a constant, not like k that you're familiar with from vertex form. But let's just multiply these out. We'll see where we get. So, right, we're going to get x squared minus 3x plus 7x minus 21. These will combine, and when it's times 1, it's going to be x squared plus 4x minus 21. And times 1, right, you're not going to get anything different. It's going to be x squared plus 4x minus 21. Now, when I take this same thing and multiply it by 5, by a negative 5, I'm going to get negative 5x squared, negative 20x, and then negative 5 and a negative 21. That should be plus 105. And likewise, if I multiply everything by 7, right, and by everything I'm talking about this stuff here, you're going to get 7x squared, 28x, and then 7 times 21, what is that? 140 plus 7, 147 minus 147. So there you go. There's many examples, long bit of notes, but it's going to get easier since you've seen so many examples, and we're going to keep working on this stuff.